students, welcome to Easy BTech, your guide for BTech and beyond. In this, today's the topic is how the BJT modes of operation. Modes of operation we are studying, how the BJT modes are operated, that we will discuss today in detail. And students, you have to observe here clearly the modes of operation of an BJT depends upon the biasing, what voltage we are giving to the junctions. Okay, that all we will discuss in detail. Very important topic. Okay, students, today's the topic is modes of operation. Modes of operation. Okay. BJT modes of operation is due to biasing across the junction. BJT modes of operation is due to biasing across the junction. Okay. Now, in the last slide we have clearly studied okay, students, this we will call as an emitter, this we will call as a base, and this we will call as a collector. And suppose you can take the type of transistor. Already we discussed BJT are of two types, that is NPN or PNP. NPN or PNP. Suppose you are taking as a PNP. Now here the junction, this junction between emitter and base, now P and N, between you are having junction. This junction is known as JE junction, and here this junction is known as JC junction. Okay, emitter to base is known as JE junction. This is known as emitter junction. Emitter junction. Next, base to collector is known as JC junction. It is collector junction. This is known as collector junction. It is emitter, base, collector. This is the formation. Now, these modes of operation in different regions. Now, due to the biasing, okay, due to the biasing across the junction, then the transistor is operated in, then the transistor is operated in, then the transistor is operated in the transistor operated in first saturation, second cutoff, third active, fourth inactive. Okay, these are the four modes of operation. Due to the biasing across the junction, the transistor, due to the biasing across the junction, then the transistor is operated in four modes. What is the saturation region, cutoff region, active region, and inactive region? Okay, that we will discuss here in the next slide. First mode is saturation. Saturation region. Now you can see this is emitter, this is base, this is collector. It is PNP, P, N, P. Now the biasing between the first, study we know that this junction is known as JE, this junction is known as JC. Now if you apply the biasing, okay, now you can see here, you can clearly understand it is emitter, it is base, it is collector. So emitter, positive connected to positive, negative connected to negative, then it is a forward bias. And here negative connected to negative and positive connected to positive, it is also forward bias. Okay, next you can remember, when diode is operated in forward bias, when diode is operated in forward bias across both the junction, across across the both the junction, then transistor is said to be saturation region. And transistor is said to be in saturation region. Okay, when diode is operated in forward bias across the both the junction, across the both the junction, then the transistor is said to be saturation region. It is also forward bias JE junction. Now clearly remember, both JE and JC both are forward bias. Okay. Both are forward bias. Okay. During forward bias, now it is a one diode PN. It is also one diode NP. Now similarly, it is a during forward bias, diode act as on switch. During forward bias, diode act as on switch. Means across both the junction, the diode is on state. Diode is in on state. Okay, that is why what we will call in saturation, BJT act as on switch. When diode is operated, when the transistor, this PN1 diode, another two diodes, the construction of two diodes is one BJT. Now here, when emitter base junction is operated in forward bias and base collector junction is also operated in forward bias, across both the junction, both the diodes are on forward bias. When it is both the diodes are in forward bias, then we will say that the saturation is operated in on switch. It is said to be on. In saturation region, transistor will act as a on switch. So due to on switch, what you can remember, it has low resistance path. It has low resistance path. This is about saturation region. Next region we have cutoff region. Now it is emitter, it is base, and it is collector. Now it is P, N, P. Now here for P and P, positive connected to negative and negative connected to positive. Again here negative connected to positive and positive connected to negative. Now you can see here under under cutoff condition, under cutoff condition, this junction will call as a JE and this junction will call as a JC. Under cutoff condition, JE junction is operated in reverse bias, and JC junction is also operated in reverse bias. Okay, both JE and JC are operated in reverse bias. Okay. Due to reverse bias condition, the diode act as off switch, that is across JE, off switch, and across JC, off switch. We will call BJT will act as off switch in reverse bias condition. BJT will act as off switch on reverse bias condition. Okay, that is why due to reverse bias, low conductivity means high resistance path. High resistance. This is about cutoff region. Next. Third, active region. In active region, you can see Now you can see it is emitter, it is base, it is collector. It is, you will see here it is P, N, P. Now here positive connected to positive, negative connected to negative, forward bias. Here negative connected to positive, positive connected to negative, reverse bias. The junction is JE, the junction is this. Okay. Under active region, JE junction is biasing. JE junction is biasing in forward. JC junction is biasing in reverse. It is JE forward, JC reverse. It is on switch, it is off switch. Due to on and off, the excellent transistor action takes place. Charges from emitter to collector reaches. Next, in active mode, transistor application is amplifier. Transistor application is amplifier. Next, it act as excellent operation due to JC junction reverse bias. Okay, transistor can act as an amplifier in active region. Next, the last region, that is 4. Inactive region. Plus emitter, base collector, PNP, positive connected to negative reverse bias, negative connected to positive connected to forward bias. Okay, this region is known as inactive region. Inactive region. It's due to this inactive, due to JE is in reverse bias. Due to JE in reverse bias, no charge carriers can travel from emitter to collector, That is why it is a poor action. It is a poor transistor action. It is a poor transistor action. Because no movement of electron from emitter to collector. Because itself it is a reverse bias. How it starts emitting? No. Now here in this active region, JE is in reverse bias and JC is in forward bias. JE is in reverse bias, JC is in forward bias. Okay. Under inactive region, transistor act as deamplification. That is attenuators. Basically, transistor never operated in inactive region. Basically, BJT is not in use in active region. In inactive region. But BJT is used in inactive region during in digital electronics. Okay. In analog circuits, BJT is not used in inactive region. As a attenuator. But using TTL mode, transistor logic. What is in TTL? BJT used as attenuator in digital circuits, in digital electronics. In analog it is not in use, but in digital it may use. Okay. Under inactive mode, Under inactive mode, transistor act as transistor has a poor action. That is why it is not in use. Not in use in this region. Simple now, you can understand here. No, it is emitter. What is the transistor action? Base collector. Now, it is an emitter. It has to emit the charges. It has to reach to the collector. From the emitter, charge carrier, emitter has to emit and enters into the collector region. It means the charges from emitter to reaches to the collector. That is a transistor action. Now it is off. If the junction J is off, maximum charges can flow into this collector via base. That is a good action. That is why it can act as an amplifier in active region. Whereas case it is off. Emitter is off. How it start emitting? No emitting. That is why it is not in use. Okay. In an inactive region, emitter is JE junction is reverse bias. Due to this reverse bias, how it start emitting a charge? No. That is why in inactive region, the BJT can act as a attenuator and it is not in widely used. So now we will see the basic comparisons. Basic comparisons. It's a comparison of modes of operation. Basic comparison of modes of operation. Okay, the first we'll call it as this will call as a modes of operation. Modes of operation. Next it is JE junction. It is JC junction. Next JE junction, JC junction. Next this we will call as characteristics. Next it is applications. Okay. Now in this first modes of operation. First one is saturation. Under saturation, it can act as it is JE operated in forward bias. It is also forward bias. Under forward, on switch. This is also on switch. Then the characteristic is low resistance path. Low resistance path. And application is on switch. On switch. Second. Active. That is, we will call as a active region. Under active region, this is mode of operations, or we will call as a region. In active, this is forward bias. JE junction is forward bias. JG junction is reverse bias. This on. This off. Means a diode under forward bias on switch, under reverse bias off switch. This is excellent transistor action. Excellent transistor action. Then it is known as, its application is amplifier. Its application is amplifier. Third. Inactive. Inactive. It is reverse bias of, it is also forward bias. Poor action. Poor transistor. Poor transistor action. It can act as an attenuator. Next, fourth. Saturation, active, inactive. And third, fourth, finally we have cutoff. Cutoff. Under cutoff, both are operated in reverse bias. Both the junctions. So due to biasing, applying an input at various junctions, you will see. Under this, it is a high resistive path. High resistance path. High resistance path. It can act as an off switch. Okay, very important table. Okay, students, this is a basic modes of operation of the transistor. How it can be operated in different modes. Okay, students, this is the today's topic. Modes of transistor, modes of operation. Easy BTech guide for BTech and behind. Thank you.